All right, Math 5500 should be a pretty brief video here. I only have three things I want to cover. First of all, I wanted to demonstrate how to get raw data into matrices using R. I want to take a data set, in .csv uh, format and show you how we create the matrices. And I want to introduce three important matrices. So it should be a rather quick video. So um, I'll tell you what. Let's get out of here. Let's grab R. And I will tell you that I'm going to use body fat. I just wanted to check there and see which one I had loaded to create the matrices. So we'll create our design matrix, and we'll create a Y vector, our response vector. So I could have my data. Oh, I don't know. Whatever. And I could have my order pairs, of course, entered this way. So 2, 7, 8, and 12. Okay. So if I wanted to look at if I wanted to use matrix operations to calculate the estimates of the coefficient, what I would need to do is I need to create my response vector and my design matrix. So my Y is going to be really easy to create here, just as we did before. So I want my lowercase y's to be the values. In row, I'm going to have my length, which is 4. I always have one column for the response vector, and by row equal true. So when I have Y, I can see that I have my Y vector, my response vector, which is good. That's what I wanted. Now, if I want to create my design matrix, remember the design matrix has in the first column all ones. And the reason was demonstrated in the previous video because of all those B0s. So when we multiply our design matrix times our B0, we get our B0, B1, our coefficient vector, we get all of those ones. Now, there's a couple ways to handle that. One way you could do that is to just go ones like that. Well, if you have a small data set, I know I need 4 because I have 4 entries here, 4 data points. It's not bad to type it in this way, but imagine having a data set of 752, whatever. You'd be there quite a while creating 52 ones. I wouldn't want to, or 752, whatever I said, ones. So this works. So I could create my design matrix by matrix, and then I want to bind my ones with my x's. My n row is always going to be equal to my sample size, and my n column, for now at least, in a simple linear regression case, is going to be 2. Again, because of my beta 0, beta 1, and by row, I want to be equal to, let's see, I have my ones first, so I want that to be equal to true. No, actually I'm wrong there. I thought I was second guessing myself. I actually need that to be false because I needed to read the 1 and then the x, and then the other 1, and then the other x, and the next 1, and the next x. So I needed to read it not by row, but actually by column. So in this case, I get, notice my x's are 1, 2, 3, 5, and I have these 1s in the first column for my beta 0s. So now, another way to create our 1s, I'll just call it 1A, just as another attempt. I can do what's called repeat. And a repeat function, I can repeat numbers. And the first thing I do is tell R what I want to repeat. In the next entry, I tell R how many times I want it repeated. So if I come back to the matrix and bind it as 1A, which is using, of course, this entry and not the one above, you can see that I'm going to get, oh, well, I just had a bozo moment. Repeat ones. And go 1A. Okay, first mistake I've ever made, right? I think we know that it's not the case. Now let's get bring body fat in. So I need to set my working directory. And go get my data. So attached it. See that have the variables. We've seen this data set ad nauseum, so it's nothing new. So let's just say that I wanted to predict body fat from triceps. All right. Well, the y vector is going to be really easy. Now, first thing I have to do is I have to find the number of entry points. I know it's 20, but let me demonstrate how I do that. So how many cases do I have? How many subjects do I have in the data set? I don't like to type out or see the whole data set because it just clutters up the output. I don't like that. It may not bother you, but it bothers me, so I don't do that. So I know that I have 20 entries, so I'm going to need the length, the number of cases, number of rows to match up. All right, so let's do Y for, just call it body fat. So I want matrix. I want my body fat entries to be included. I want 20 for the row. We always have one column, and by row equal true. So Y for body fat is exactly what we would think it would be. Our design matrix, I'm going to need to create my ones. So I'm going to repeat 1, and I'm going to do that 20 times. So now my X is going to be matrix. I'm going to bind my ones with the triceps. In row, I know I need 20, and in column, I know I need 2. Again, we're doing a simple linear regression. We have two estimates, beta 0, beta 1. That's the number of columns we need. Once we move into big boy, big girl stats, let's say we have a multiple regression model where we have 5 predictors. Well, then we're going to have 5 columns. So by row equals false. Let me put false there so you know what the F means. So when I do my X now, you can see that I get exactly what I want. Now, there are a couple of matrices, and I want to go back here. There are 3 matrices I want to introduce now, again, so we can hit the ground running in our next lesson. One matrix that we see a lot is Y transpose times Y. And if we think about this, this is just our Y values, 1, Y2, Yn, times our Y vector, our column vector. So again, transpose just says that the columns become rows. We just interchange the rows and the columns. Now, if we multiply this thing, we know that we have a 1 by n, and we have an n by 1. So these two line up. So we know that we can multiply the matrices, and we know that the product is just going to be a 1 by 1. So how do we get that? We take a linear combination of the rows and the columns. So we get the y1 times y1 plus y2 times y2. So it should be pretty clear that in this case we get what? The sum of the y squareds. Next matrix I want to look at is X transpose Y. Well, X is like, 1, 1, 1, 1, and then X1, X2, X3, and so on. So the transpose of that is just going to make all the ones are going to go in a row. Again, just interchange the rows and columns. So the y vector is as given. So what we have here is we have a 2 by n and an n by 1. So we can multiply and we're going to have a 2 by 1. Well, if we look at this entry is going to be a linear combination of the rows and columns. So that's just going to be 1 times y1 plus 1 times y2 and so on. So we should see that this entry is just the sum of the y sub i's. Put the y sub i's there. Next thing we get is we get x1 times y1 plus x2 times y2. Should be pretty obvious that this is just the sum of the x's, the product of the x's and the y's. The third matrix that I want to show you is X transpose X. This one comes up a lot. X transpose again from up here is going to be 1, x1, x2, xn, 1, 1, x1, x2, xn. So we have a 2 by n and an n by 2. Again, those are the same, so we can multiply them. So we're going to have a 2 by 2 matrix. It's easy to see what we're going to get. If we take a linear combination of row 1, column 1, we get 1 plus 1 plus 1 plus 1, well, n times. Second thing we get is a linear combination of the first row and the second column, so we get x sub 1 times 1 plus x sub 2 times 1. Should be pretty easy to see that this is just the sum of our x sub i's. Linear combination of row 1, column 1, x1 times 1 plus x2 times 1, so on and so forth. Again, same thing. And then we can see that we get x1 times x1 plus x2 times x2. We can see there that we're getting the x sub I squared, and we get the sum. So to create these values in R, what would we do? Well, remember for the y transpose, we would do transpose y to multiply, parentheses, multiplication, parentheses, percentage sign, multiplication, percentage sign times y. And again, we get a 1 by 1, which is 261. To get x transpose times y, so we're going to take x transpose times y. All right, what's going on here? Okay, I'm going to have to get back with you on that one. I don't know why we have a 2 by n and an n by 1. I don't know what's going on there. That makes no sense. So we have a 2 by n And then y, we have a, okay, what's going on here? Oh shoot, I know what it is. I had to use YBF. Uh, yeah, I had a, I was using the Y from the, well, what I created before. Yeah, that was not real bright. So hopefully it makes sense that I named the X here, but then to try to differentiate this Y, excuse me, with the Y for the body fat, which I'm using for this illustration. All right, just a bozo moment by me. And then X transpose X. Gives us a 2 by 2, just as we saw earlier. So gang, that's all I got. We will hit the ball running. We're going to learn some really cool stuff in lesson number 6. Well, I think, yeah, or lesson number 5. We'll get into multiple regression coming up. So learn some pretty cool stuff in the next lesson. So take care.